Right. Unfortunately, I guess we got scheduled against Brian Freeman, so that's probably why there aren't so many of you here. I'd much rather be listening to Brian Freeman as well. So, yeah, real shame on that one. But yeah, what I wanted to do was just give you kind of an update on OpenDaylight BGP, but particularly with a focus on use cases. I don't know if anyone here was the tutorial we did on Monday. One or two, yeah. So we did a tutorial on Monday afternoon, and I did that along with 3 of the guys from Brocade. They're coming in after this to do a talk more about sort of what's new in ODL Boron with respect to BGP. So what I wanted to do was focus on use cases that were already there as of Beryllium, rather than looking at some of the new stuff. So I was going to give a very brief overview of the BGP plugin and the PCEP plugin and how the project hangs together, and then look at these 3 use cases. I'm afraid I failed to stay up all last night hacking, so the use cases may or may not work, but I sacrificed to go to the demo gods, and there's some hope at least. So the 3 I wanted to look at, one was traffic optimization using BGP and PCEP, and this is really where ODL BGP came from, this concept that we can use BGP LS to learn stuff about the network, and then use PCEP to program LSPs into the network. For a bit of added fun today, I'm going to attempt to use segment routing. This is in some ways similar to the demo I did last year, but in that case it was using RvesvesD. Then go on to look at DDoS mitigation using FlowSpec, and I'll show you some slides on that, and some other approaches to DDoS mitigation. And then finally look at BGP and how you could look at overriding best path selection using BMP. There's a couple of options there, and we can go into that, and I can show you some of the infrastructure, and 100% get that one running. So the overview. So here's how it all fits together in terms of OpenDaylight. So the 2 southbound plugins, PCEP and BGP. BGP is used to learn routes from the network. Now the thing is that, as I say, we kind of started with this for BGP link state. What's happened over time is more and more address families have been added. So BGP itself started out as IPv4, of course. And then what happened was multi-protocol BGP was developed, where using the inherent extensibility of BGP in terms of TLVs, we could just add more and more address families. Be interesting to actually get a sense of the room. How many people here would say they were software developers? So perhaps a third. And how many would say they were network designers, architects, etc.? So perhaps slightly more on the network side. So I guess most of you guys are probably well aware of BGP already. And so over time, we've added these additional address families in ODL. So IPv4 and IPv6 unicast, labeled unicast, so that's RFC 3107, where you have a route that's advertised with an IPv4 prefix, but also with an MPLS label. FlowSpec, initially I think that came in Lithium and was V4 FlowSpec only. As of Beryllium, it has V4 and V6. And then also IPVPN and EVPN, but those are new in Boron. And as I mentioned at the beginning, it'd be probably good if you want to know more about those to wait for the next session, which is going to be the guys from Brocade talking about some of the new things in ODL BGP. That's actually one point, I guess, to make now, is that initially, ODL BGP, we were very much driving it from Cisco. One of the great things as this community grows and builds is we've got more developers coming in and making changes to it and committing things. So we've got the team from Brocade. I was noticing actually a bug that I'd raised the other day relating to EVPN, and I was noticing that a patch had been provided for it, and that was actually done by somebody from AT&T. So we are seeing developers coming in from other organizations on this, so that's great. So this slide I'm bringing up really because it's better than the one I did last year, and this is the one the Brocade guys showed the other day, and I think it's actually really helpful in terms of understanding the pipeline of what happens with BGP routes, but also some of the things we might want to do in Carbon and beyond in terms of potentially changing how we do this. So for each BGP peer that you have, you will have an adjacent ribbon. So this is absolutely standard BGP stuff that all routers do. The adjacent ribbon has every route you've learned from that peer. You apply an import policy. Now in OpenDaylight, the import policies aren't programmable. They're very basic in terms of, is the route basically legal? Does it have our own AS in, that sort of thing? I think over time that's something we'd like to make programmable. And I think the question then becomes, do we do that using sort of route policy language, a la what you might do in XR or Junos, etc.? Or would it be better just to provide some way that people could plug in their own policies using, whether it's done with Yang models or whether it's done by putting in Java code? That's something I think we need to look at. From that, we build an effective ribbon. Now, the effective ribbon really is the routes that have passed policy. So typically, again, on a router, this is where you'd say a route policy whatever in, and you'd filter out routes that you didn't like. The next part is the decision process. So I can see Bo sitting over there, and Bo, I'm sure, and in fact, Chris in front of him, I'm sure these are both men who once upon a time would have had printed out on their cubicle, or in Chris's case, if he was in the UK at that point, printed out on his desk, because we don't really do cubes, a thing saying this is the BGP decision process. And you could download this from the Cisco website, and it went from, was it 1 to 13 or something, the different steps in the decision process. And we all had that. I mean, I was a network operator back in the day. And you always had this thing written up there, and great, you knew the process by which you decided which routes made it into your lock rib, which is the output of that decision process, and which ones didn't. Now again, this is where I can see the value in us becoming more flexible in OpenDaylight, because ultimately we're not a router, we don't have a fib. What we have is topologies, which we'll come on to next. So there might be value in being able to do different forms of best path selection to get into that lock rib, and we've got some ways we can override it, either by spinning up multiple ribs or doing some tricks. I'll show later, we can learn from BNP and push out with BGP, those sort of things. But ultimately, it might be good to have more flexibility as to what decision process we adopt. I mean, you could imagine, a Yang model that literally has the default is here are the 13 steps in order or whatever, and you can just play around with it and reorder them, those sort of things. So, as I mentioned, for each peer you spin up an adjacent ribbon. For each peer you spin up an effective ribbon, but you still only have the one lock rib, and that's because you're building one rib for the routes from all the peers. Sorry, I kind of change at will from English to American. I'm really sorry. Routes, you'll forgive me, I'm sure. Now, if you're acting, more or less as a router, what you then do is you apply an export policy, which again in OpenDaylight isn't programmable. You build an adjacent rib out, and again, you build one of those for each of your peers. Now, the thing there is this is sort of the normal sort of route reflector kind of use case, I suppose. And that is one use case we could use OpenDaylight for. But I suppose what we probably see more than this is examples where either we're using BGP just to learn stuff, or where we're using it just to program stuff. And in the context of using it just to program stuff, this is where the application rib comes in. So if you think back to Yang models, and again, anyone here who's has more sort of OpenDaylight experience probably has the head a little bit around Yang models. So any data in a Yang model is marked as either config or it's not config. And what we do from that is we build the separate trees, the config tree and the operational tree. Now, the ribs are all operational data, because this is all stuff, as you can see on the diagram, we've learned it from our peers. So it's operational data, nothing was ever configured. So the question then becomes, well, how do we inject routes in? And the way we do that is by having a configuration rib, which acts as a sort of special kind of peer to the application, to the lock rib. Initially, and I mentioned this, I think, last year, it was defined as an iBGP peer, but that caused us some issues in that if you had other iBGP peers, the route would never get reflected to them. So what we did was we made it a special case, which is a bit more like a route reflector client, but just doesn't add on the, what does our clients add on? It's the cluster IDs and those sort of things. That doesn't get added on, but the routes will make it to any iBGP peers. And so what you can do is you can write your external application. It can call through with RESTconf, inject a route through the application rib, and that will make its way into the lock rib. Now, I've done that using, for example, Python scripts and that sort of thing. But of course, the other thing to always remember with OpenDaylight is that when we build APIs from the models, we build the internal and external APIs. So equally, there are internal Java APIs that you can call to do this. And so again, around sort of performance, you might want to write an app inside OpenDaylight that would be learning some stuff with perhaps BNP or something else, and then we'll be pushing routes in using the app rib, but as an internal application. Because then rather than having an app that sits northbound of OpenDaylight, which has to learn stuff, advertise stuff, and have its own sort of external database for deciding what its policy is, you could just make the policy a Yang model that you push into OpenDaylight, and then have the app running there just locally inside the controller. I then also mentioned the case where really we're much more concerned with learning things than advertising them. And this is where I said earlier that we don't have a fib in OpenDaylight, though to some extent watch that space, because anyone who was at the FIDO stuff on Monday will have heard how using things like Honeycomb and VPP, we can now build these sort of software routers, which could quite naturally align, I suppose, with OpenDaylight and using those as a sort of fib of some kind. But what we have today is the topology exporters. Those will take what we learn in the RIBs and advertise that out to topologies. So rather than building a fib, we build a topology. And so far, there are just two topologies. So there are the IPv4 and IPv6 reachability topologies, and those are generated from the IPv4 and IPv6 RIBs. And then we have the link state topology that comes from the link state RIB. Now, the link state topology is a true topology. It has nodes and links. What you'll find with the v4 and v6 ones is they just have nodes, which are the next hops that we've learned from BGP, and then for each of those, they'll have a list of prefixes that are associated with that next hop. But if you look at the Bgp Ls topology exporters, this is sort of the key one. Of course, I've missed out the details, I suppose, around the adjacent ribbon and the effective ribbon. But what you can see is this is how we're leveraging MDSAL and OpenDaylight. So we're learning from BGP, so we're learning BGP link state routes. We're pushing them into the operational RIB. And then we have this topology exporter application, which in a sense, you can see this as one of those applications that sits in the middle of OpenDaylight, although it is part of the plugin project. It's not really part of the plugin, because here we have an application that's learning from, using MDSAL notification to learn from that operational RIB, and it's then applying a transformation, which results in it pushing data into this operational topology. And then, again, internally or externally, and we've shown the external case here, RESTconf could pull that data out from the topology and you can display that. Or you can interface with something like a path computation element. And that's really the first thing I'm going to demo today. Possibly the only thing, given how some of the demos are going. Yeah, so I should have said be interactive the whole time. That's good.
In the last diagram, the Java controller, is there every device, every router in the network peering to that? Or is it pulling the routing table information? How's that interacting?
Yeah, so if we quickly flick back to the overview picture, what you can see here is you only have to have a BGP peering with one of the devices. And in fact, that's one device for each IGP area. Now, in fact, you could just have one, because what you can do with BGP LS is if you have a BGP LS speaker in each IGP area, those BGP LS speakers could be paired with each other and you could be bringing stuff in. The only thing at the moment is the topologies we generate, they don't do a very good job of consolidating the different areas, and that's something I think we need to get around to with probably using the topology processing framework. Because at the moment what you find is the identifier for a route really encodes the IP address of the router that advertised it to you and those sort of things. So for example, if you had, this picture isn't the right picture, I guess, for that, but if you had, say, an OSPF backbone and you had a speaker on the border of the backbone with each of 4 other areas, what you'd see is you'd get 4 copies of the topology for that backbone, and then 1 copy for each of the 4 areas around it. I think if you went to pairing the BGP LS speakers with each other and having just one of them pair with ODL, that would get you down to 1 picture of the backbone. But you'd still have these 4 separate pictures for the other areas. So we do need to do some work to collapse that together. Okay, I'll just skip forward through this. Sorry, the problem with animations is you can't quickly skip through slides. So looking at the topologies, and I suppose these are the 4 topologies we have today with BGP. Now the key thing, of course, to remember here is that OpenDaylight is really all about topology. So to my mind, maybe it's my personal bias, but I see the key thing with SDN controllers as being topology. And the reason for that is it's topology that enables you to deal with the network as a whole rather than dealing with individual devices in the network. The other great thing is that the topology model that we have in OpenDaylight, which is effectively the I2RS topology model from the ITF, quick plug for it, it's in, I think it's in Working Group Last Call at the moment. So anyone who follows the ITF, have a read of the model, and if you like it, say it's a good thing. The great thing with that model is that in a sense, in programming terms, it's a bit like polymorphism, that you can have all these different types of topology, and you can deal with them without necessarily needing to know which type of topology it is. So what happens is we map information from each of those individual protocols that builds a topology, that will get mapped into the nodes and links in the topology. Then anything that we have left over, because we couldn't fit it in somehow, we'll handle that as an augment. So we'll have a Yang augment for the topology for example, PCEP or for OpenFlow or whatever else. And so that data gets put there. But you could have an application that just draws topologies and just worries about nodes and links and treats the identifiers as opaque values. That application could draw an OpenFlow topology just as easily as it could draw a link state topology. It shouldn't have to know what type it is. One other thing to mention, though, is that the topologies are changing. So the drafts that are in IETF Working Group last call, the draft there is a new version of the topology model where what we've done is we've separated out the nodes into a sort of network model, which we then augment for a topology model that has links. That's a plus because a lot of what we're using the model for, and I guess this is why I've got this bold, non-bold split. As I mentioned, V4 and V6, there are no nodes, there are no links. Likewise with PCEP. So those could go in the sort of network model, and it would only be things like link state or like OpenFlow that would require links and be in that augmented model with topology. Of course, from OpenDaylight perspective, the challenge is we're going to have to implement that. So assuming it gets through to RFC soon, then I would expect that we'd implement that in Carbon. Now, of course, each protocol is going to have to make that change. And in usual fashion, I'm guessing what we would do is we'd try and support the current model, say in Carbon, and the new model, and then in Nitrogen, we'd drop the current model to give people time to adjust their APIs or use of APIs. So this first use case, traffic optimization. So looking at BGPLS and PCEP, and as I say, this was really where we came from in OpenDaylight with BGP. So this is an absolutely generic model that I tend to follow for almost any SDN application. And that's to say that really the value comes when you have more than one southbound plugin you're using, and where you're typically using one southbound plugin to learn stuff about the network and a different plugin to program stuff into the network. So in this case, of course, quick aside, if you're looking at something like reactive OpenFlow, of course, that's just one protocol, and it's not really one of the reasons, but I'm not a big believer in reactive OpenFlow, and to some extent, you can do proactive stuff quite well with it. Reactively, it probably doesn't scale, but you could see applications, for example, with OpenFlow, where you might just be using it for the packet punts to learn stuff about the network, or where you might be using stuff proactively, but you're learning stuff through some other mechanism. But in this instance, we're using BGPLS to learn and PCEP to program. Demo time. So this is where we hope that something works. Got to find where I put the demo, of course. Too many windows. Here we go. So here I have a network up and running. This is running in Cisco D Cloud. Maybe I should zoom in a bit. So here we have a US West Coast topology, and we're here at the top of the diagram in Seattle. And then you can create LSPs across the network. And of course, the fun thing here is I haven't actually restarted this anytime soon, so it's entirely possible this won't work. And what we've done is we've actually just made this change in the last few days where we've now got 3 different ways of choosing a path across the network. So we can look at the IGP metric, we can look at the number of hops, or we can look at the T metric. Or if we don't want to do that and have the system calculate paths for us, then we can go in a manual approach and just point and click to get something across the network. So Seattle to San Jose, deploy the path. Yes, and the path's now been deployed. So that's very simple, of course, but what we can do, and again, you can list the paths that are in the network. You can delete them if you want. You can compute a different path. So for example, on the same thing, you might say, well, I want to do another path that goes all the way around the houses. I'd have to give it a different name. And what happens is it goes off with PCEP and programs that path. Now, in the case of, we're using PCEP SR here, so it's using segment routing. So we're using, and that's what these little green sort of buttons are here. They show that the router's got PCEP enabled and it's got segment routing enabled. So with segment routing, what's happening is for each of these routers, we're learning not only its IP address, but also the nodal segment associated with it. We're also learning the addresses and adjacency segments for the links. And then when we set up a path, what we're doing is we're basically pushing in the set of nodal segments for those routers on the path. So what you'll have is a label stack that label stack will then be, a label will get popped off at each hop. Now, of course, you could do something much more flexible where you just put in certain waypoints and let the system find its way to a waypoint. So you don't need a stack with a label per node. I guess that's nothing to say about PCE and OpenDaylight. So this application is a relatively straightforward Python application that we wrote to sit on top of OpenDaylight. So it communicates with OpenDaylight using RESTconf, southbound. Northbound, what it has, and you can see, if you look at my URL here for a moment. There you go. You can see it's on port 8020, we're running a REST interface. I'm actually running that on my local PC. But in this instance, what I've done is I pointed it at an OpenDaylight instance running in dcloud, which is a cloud infrastructure Cisco uses for demoing stuff. And so my browser effectively is connecting to that local server. The client-side stuff is all JavaScript. So in that sense, it's a sort of three-tier thing that you have the JavaScript on the client, talking JSON to a REST server, which is implemented in Python. That REST server is then using RESTconf with JSON to talk to OpenDaylight. And so, for example, the OpenDaylight topology that we have coming up is using the I2RS topology model where links are unidirectional. And what's happening within the Python application is that's being transformed into a topology where links are bidirectional to simplify it, but also because that then allows us to hand off to the graphing tools that we're using. So I believe this one's using the Next UI, which is an open source JavaScript graphing tool. So as another example,
is this your application available?
Yeah, it is. You can just clone it off GitHub. So I think it's on GitHub.com. Let's have a look. This is also the fun bit where you realize what you've been watching recently is being shown on the screen and recorded for all posterity. Fortunately, though my bank thing's there, I don't think it has my banking details.
This is why they invented incognito mode.
Yeah, exactly. So I think it's in Cisco DevNet, Pathman SR is my guess. Yes, there you go. So if you were to go to Cisco DevNet Pathman SR, you'd get hold of this. I've actually cloned the dev branch because that's the branch with the T-metric stuff in. And we'll fold that into the main branch soon enough. So it's probably a good demo application to have a look at just to see how you might build an external PCE. I think
it matches very close to something we're actually doing.
Oh, okay, interesting. And it's kind of nice, like, yeah, because you can see the sort of code examples of how you do the REST JSON stuff from Python, and then how it provides a northbound API towards JavaScript.
This is just actually once the path is figured out, it's pushing the path into the controller, or is it actually doing computation based on latency or bandwidth loading?
Right. So what it's doing in the computation. So if I come back to this is the wrong one, isn't it? Yeah. So what it's doing when we go in and say we want a path. So as your path setup, compute path, and so you just give the nodes that you want, and then what we've done is we've done a modified version of Dijkstra, where instead of having just the shortest path, we generate every possible path. And again, we can do that, also using hop counts. We can also do it using traffic engineering metrics. So I didn't have time to set that up for this, but you could, for example, say, well, San Jose is a big traffic source. We don't want to transit San Jose. So you could up the metrics around San Jose, but then you could say, well, we won't up the T metric because, you could say, well, if we've got traffic going from Seattle to LA that requires low latency, we don't want it to go around, Minneapolis and Kansas City, for example.
The reason I ask is because without SDN, a lot of people have turned to auto bandwidth in their MPLS or SVPTE. But that gets you back to each individual router doing its own thing, and Google's posted some good information about how that results in suboptimal paths.
Yes.
And if instead you use bandwidth utilization on your links into maybe TE or some sort of path selection for the computation, that would actually allow you to eliminate the usage of auto bandwidth to do basically the same thing with this tool. But it's that engine to accomplish the same auto bandwidth is kind of the nirvana I've been looking for.
Yeah, and I think there's a very strong alignment also between segment routing and SDN in that context, because once you go to segment routing, you no longer have signaled LSPs through the core of the network. There is no way of tracking the bandwidth through the network. You've got to do it offline, or in a separate system, I should say. The other thing, of course, is yes, Google are correct, and it's I suppose self-evident that where you want to optimize usage of the network, you'll get a more optimal solution if you have a centralized view than if each router takes its own view. So that's clear.
So basically, we've got some more work to do, maybe in another application than OpenDaylight that pulls in and populates in the data store the bandwidth utilization.
If you want,
used by some other
right,
then do this.
Yeah, if you wanted to use bandwidth utilization, I've actually been helping one of my colleagues who's doing a master's and who she wanted to do stuff that was a bit more dynamic. So that's partly actually why we put the T-metric stuff in, so that she could use it. Sorry, because I'm connected to batteries. And I think what she was doing as a sort of as a hack for what she was doing was to put in use EM scripts. I can't remember if she was going to measure latency or bandwidth utilization or something.
Simply used latency, but what we wanted to do at T-Mobile was bandwidth utilization, equivalency of auto bandwidth, but without the suboptimal routing that Google reports.
You need a heuristic to dampen the changes.
You do.
Otherwise, the loss rate.
Yeah, you need that. You'd need that.
Are you saying that for the SDN or for the auto bandwidth?
Either way, because
anything like that.
even if it's centralized, if you shift all, say, all your traffic to this link, then the next quantum that you go measure stuff, you can say, oh, that makes sense, so shift it back.
That's the whole idea of the SDN is to do that calculation ahead of time to figure out what the results might be before you make the step. Whereas if it's auto bandwidth, you can get those fluctuations of, our routers arguing with them. I want the bandwidth.
Yeah, and in terms of an information source for that, I suppose what we'd probably look to do is use streaming telemetry to get regular bandwidth data values and pull them up into the controller. So yeah, maybe that'll be my demo next summer, wherever we do the next one. Yeah, and so also, I think I did mention, you can do the sort of manual path selection where you just click on nodes. Whoops. What have I done? Your path is not. I'm probably selecting it with the wrong thing. See, that's a bit random, isn't it? I decided to do something that is just never going to work.
That's why you're a vendor and we're the operators.
Yeah. Oh, no, that works. It's kind of unfair, to be honest, because I was an operator until quite recently. But I was incompetent, so they got rid of me. Sorry. Yeah, so that's that one. Where's the deploy button on this? See, I've lost the deploy button. There you go. Shows they changed the UI on this, which was helpful. Oh yeah, deploy. And then you need to give it a name, call it manual, and off it goes, and that'll get deployed eventually. Yeah, there you go. Yeah, I mean, in some ways, I'd have to say that, Pathman here, it's kind of a demo app. We're not really expecting carriers to deploy this one into production, and I think.
Too late.
Too late, you've already done it, yeah. And I think the other question then that comes up also is, do we build PCs like this on top of OpenDaylight, or do we build them inside? And I think some of that may come down to the sort of the level of responsiveness versus the amount of sort of offline computation you want to do. So it may be that you see integrated PCEs used for quite short timeline kind of things, quickly finding a better answer. But then you see these more sort of high-end engines of the likes of the Way platform that can sit on top of a controller, and they can do that kind of more planning-based optimization. Right, so that's that one. Let's go back to slides. Now we've got one demo that's worked, which I think might be the only one. Right, DDoS mitigation. Yeah, so BGP flow spec. So really this is where we said, well, some people much smarter than me said, we want to be able to stop things like DDoS attacks. And what we know as service providers and as vendors of high-end routing equipment is that BGP tends to be our preferred means for advertising things around the network, and it's definitely our favorite catch-all control plane. So rather than implementing something like OpenFlow, where you have this ability to specify, here's something I want to match in an Ethernet packet header and match all the way from the from the MAC header onwards, why don't we take a more IP-centric way, where we use BGP to advertise these matching constraints, and then we use BGP also to advertise the actions that we want to take using extended communities. And the nice thing there, of course, is that you can leverage the whole sort of BGP route reflector infrastructure. I guess what you don't have here is kind of the analog of the packet punt, really, though, of course, you can do things like traffic redirections, so you could achieve that, I guess. But it's not really designed for that reactive open flow equivalence. And I think the most common place I've seen it being deployed is for DDoS mitigation. Clearly, there are other things you could do. You could, for example, use flow spec to direct things to, say, a transparent cache, something like that. But I'm guessing most people have done that through config rather than anything as dynamic as BGP. There are actually a couple of different ways, though, you can do DDoS mitigation. One is using flow spec. The alternative is to, if what you want to do is just stop attackers, so you're not really worried about what they're attacking, and you're thinking more in terms of, OK, here's a bad actor, I don't want to drop their packets. What you can do is use generic v4 or v6 unicast, but if you turn on unicast RPF, then now what you can do is advertise a route, a /32 that matches, for example, the bad actor, or could be a whole prefix you want to take out. You could advertise that, but advertise it and point it at 192.0.2.1, which is sort of by convention what you use as a black hole in routing. And then on your various routers, you'd have that tied to null 0. And so then, when the packet arrives, the router will do the lookup and say, OK, is this arriving on the interface I expect it to arrive on? And what it'll say is no, because I expect it to arrive from the null interface, and it'll drop the packet. So that's the non-flow spec way of doing it. The flow spec way of doing it is to say, well, OK, we've got an attacker, and perhaps they're going after our DNS. So it's a DDoS attack, very widely distributed set of IP addresses. Perhaps these are coming from people out there on the internet. They've got no business accessing our DNS, which would, I guess, kind of beg the question why you allowed them to access it in the first place. But what you could do in that context is you could advertise a flow spec route via your route reflection infrastructure. So we're pushing in a route here, gets the route reflector. The route reflector then pushes it out into the network, and at that point, the attack traffic will stop at the first device that has that filter. Because that filter says anything going to port 53 to that destination address of the server and coming from these ASs or these prefixes, whatever, we're going to drop that. But of course, it's not just about dropping. You can do things, as we saw on the previous slide, rate limiting, those kind of things. So it's a useful tool in general. It's interesting to know from a carrier, for example, have you deployed this? I mean, without necessarily BGP, without OpenDaylight, but have you looked at BGP flow spec?
I've definitely looked at it. I don't know whether we use it.
Anyone else here had a look? One or two. Anyone deployed it? Interesting. OK. So the other thing I want to look at, and I'm probably way ahead of time, because I had some issues setting up my FlowSpec demo, largely owing to the fact that most problem I've got is most of the kit I have, of course, is virtual kit. I know there's some people here who've made it work with the CSR, but the XRV doesn't support FlowSpec. You can advertise the routes in, but it won't actually take any action because the forwarding plane is an emulation and doesn't have that capability. So I wanted to look at BMP and then look also at how BMP might tie into a use case where we're overriding best path selection. So BMP is BGP monitoring protocol. It came from the GROW working group in the ITF. It's now an RFC 7854. And what it does, if you remember back to when I talked about the adjacent ribbon, the effective ribbon, what BMP lets you do is access those on your peer rather than just getting the lock rib. So imagine now that you've got a router that's connected to multiple upstreams. What's normally happening, of course, is if your controller peers with that router, all you're going to see is which addresses the router chose from those upstreams. Now, if you want to start adjusting things in terms of how you load balance your traffic, what you'd really like to know is what did all my upstreams advertise me before I applied my policy, so that now I can adjust my policy to get different behavior. So that's what BMP would let you do. So in the BMP case, you can see that adjacent ribbon and that effective ribbon for each of them. Now, of course, the corollary of that is you can get an awful lot of prefixes. So imagine you did have 4 or 5 upstreams, and they're all giving you a full route feed. You're now getting 4 or 5 route feeds worth of adjacent ribbon, and the same again of effective ribbon, potentially. But it can be very powerful for any kind of analytics and that sort of thing. I see some of the presenters of the next session walking in. Excellent. Well, if I finish early, you guys can start early. You never know. So what I was going to do is look at this sort of use case, which may work. So if we advertise, what we have is an AS that's advertising a prefix. What it's doing, though, is it's disaggregating that prefix to someone else, which is resulting in 65504, which is our AS, learning that prefix disaggregated through a longer AS path than the path that it learnt it aggregated. So this comes back to this best path selection thing. However, the problem in that case is this isn't just about reordering best path selection. Best path selection only applies once we've got two prefixes that are the same length. The longer prefix will always win. You'll never get to best path selection if you have a longer prefix than a shorter one. So what we could do potentially, of course, is figure out a way to either filter out those disaggregated prefixes on the longer path, or we could inject disaggregated prefixes with a fake path that's the shorter path. So what happens is the routes, I'm trying to go through sort of step by step. So we have our border routers are running BMP, but also running BGP to the route reflector. And so we see the aggregated prefix, and then we see the disaggregated prefix arriving. And then we can see through BMP, we can get at those prefixes. Now, I just restarted the controller. So this is the fun part. Talk amongst yourselves. Yes, I restarted it. So let's go into our friendly postman, and let's set up BGP. So probably want to put the ribbon. I think that's the right device. That is correct. Seems happy. Let's put in the peer. Let's check I'm putting in the right peer. I probably only want to do v4 unicast in this case. So let's put that in. And so now with a bit of luck, the BGP session will come up. So let's go to that peer, and I'll maximize this so we can actually see it. Put the right one. It's this one. Let's put it aside so we can see it. So we can see we've. So you can see on this router, if we do a show route. So this is on the route reflector, and what you can see is it's learnt. BGP route, isn't it? I think, yeah. So let me do that. No. Of course, yeah. So you can see this 172.16.0.0 has been learned through a single hop AS path, 65506. If we look at the /17, though, it's been learned through a 2-hop AS path. So with a bit of luck, what we'll see if we go into ODL itself, I need to check. I see, I put that in. So oh yeah, we don't need BMP on this one, do we? We need it on the other ones, so that's fine. So let's look at the routes that we have. So OpenDaylight should have built a lock rib. And here you can see that rib. You can see that we've learned the /17. We've learnt it through XR2, which, if we remember back to our slides, is the bottom one where we've got the disaggregation happening. We'll also see the other /17 again through there, and then we'll see the /16, which we've learned through XR1. And it has the shorter AS path, so that's kind of as we expect. So the next thing is, what do we see through BMP? Now BMP is, find my, yep. Maybe I didn't add the feature. There you go, you always got to watch out for that one. So look at ODL, this guy. So here's OpenDaylight. not there? Okay, I'll just SSH in. The usual thing about making sure that SSH doesn't complain. How much is it again? You're right. Get rid of that. Right. Feature. So ideal BGP CEP BMP. That's our BMP feature. Well, notice it wasn't installed because it took a second to come in. Okay, you can see at least one of them has reconnected. That's XR1, isn't it? It may be on XR2. I hadn't set it up. And so now we should see some BMP information. Oh, there you go. So you can see the router ID that it's learning from, the status, and then from that router you can now see that what it's giving us is a list of its peers. So in its case, it's only got one peer, and that peer is XR3. And then you can see this is the adjacent rib in, the pre-policy rib. You can see that 172.16. And then you can see, hopefully, oh yeah, it doesn't have the effective rib in this one. I think that's right. Yeah, there was an issue with the post-policy rib. I thought they'd fix that. Am I looking in the wrong place? Yes, there is. Yeah, it doesn't need to. This is Beryllium SR3. It doesn't need to pick out the post-policy rib correctly. But then, hey, we have pre-policy, so that's a start. And what you can do, of course, is you can run it up on the other router. So my password. Host. What's OpenDaylight? OpenDaylight for some reason listens on port 12345. You can change that, of course, through the then router BGP neighbor. It's going to be, yeah, hang on, I can't remember what the neighbor is. So the one that's external is going to be that one, isn't it? The second one. So I think that's right. Maybe just send everything. Oops. Hopefully that's fixed it. So what we should expect to find is another BMP server up in OpenDaylight. So if we go back to, just check it's there. Yeah, that's up. So now if we go back into Postman and pull this again, we should now see information from both of them. So there's 51. You can see it's actually said it's XR1. And then on 52, we should now see the disaggregated routes with the longer paths. So I say in this case, you don't, in fact, it's showing me the very long path from 172.16.00/16, sort of round the loop. But of course, that's on the pre-policy rib, and that will never make it into the lock rib because it's got our own AS in it. So it won't make it even to the effective rib in, and that's XR2. Now, you wouldn't necessarily need to use BMP in every case for this. There are cases where BGP would be sufficient. But as I say, one of the issues there is you may end up having to spin up both two separate ribs and effectively have an app that's taking information from one rib and putting it in the other rib. The nice thing with using BMP is by default, it's a separate data tree to the one we get with BGP.
A question on your slides,
Uh-huh.
what you had there, that the bullet list you have at the top should, second one down, should that be AS 505.
Well, in this case, what was actually happening was the source AS was disaggregating towards one of their other peers, and that was resulting in this longer path coming into sort of the home AS. And that was the issue, was that as a result of that, the home AS was going to end up sending traffic through the longer path rather than through the short path that the ISP preferred. So this is a real use case. I guess in terms of then how you program that, there are different options. You can use BGP to push stuff in, or you could use, now sometimes that can have issues around lying about your next hops and that sort of thing with iBGP. The other approach, of course, you could take is to say, well, if the routers support netconf Yang, then what you can do is go into the router, and then in the router you can make the change on the peering router. Now, of course, because you're using BMP in that context, you still know the adjacent ribbon, so you still know what routes have been advertised to you, even though you haven't accepted those. So that gets you around that problem of, okay, we've now blocked something, and now we have no idea if it's still being sent, because we blocked it, so we can't see it. So again, that's where BMP can be quite handy. Now, of course, what you can do then, as I say, is inject routes back in. Now, with the app rib on ODL, how that works is you have to set it up first. Pick an address, any address, and that should be set up. And now what you can do is you can just push routes in. So, where we go? 192.16.0.0/17. And you could say, well, the next hop was going to be, I can't remember who the next hop was for that. I have to find out. It's going to be XR1, isn't it? Because it's doing next hop self on that, which is, yeah. And so if I've got that right, of course I've got to get this right here as well. It's one of the annoying cases where we have to escape the URL because the key for this list has a slash in it. That seems to have gone in. It does. Question is, have we actually seen it from anywhere? This is the bit where the demo will probably fail. Oh, there you go. Yes, that has fixed it. So now, on this route reflector, what you can see is instead of for that first /17, it's now pointing it at the shorter path. It's now sending it via 192.168.0.1, even though that's not how we learned it. So we basically advertised a route in that overrides the route that we learned. And I think really that, in a sense, I am really early, but that probably gives us time to have discussion. Actually, I'm not that early, am I? I think it was 11:45. I guess in summary, that's my sort of takeaway for a lot of this with OpenDaylight and BGP is that, really where we want to be looking at is using OpenDaylight to do stuff that we couldn't do just using our routers. So we can't override best path selection using a normal router. And as I say, even best path selection, even overriding that may not be enough. There are cases where you want to override it in a way that means you want a shorter prefix to win out over a longer prefix. And for that, you really don't have much choice but to have some kind of a controller platform, an off-box platform that lets you do those kind of tricks. But as I say, really the other great value prop for me here with OpenDaylight is the fact that we have access to all these different southbounds. And so in the vast majority of cases, I would expect us to be using one protocol to learn stuff and a different protocol to advertise stuff. And again, through having all those different southbounds, that becomes possible. Because if you're not doing that, if you just want to advertise some routes, I guess you can do that with XBGP, you can do that with GoBGP. The value here in OpenDaylight is the whole ecosystem and the fact we have all of those plugins southbound. And so we can use BGP to learn something, PCEP to program it, or BMP to learn BGP to program, et cetera, et cetera. As I mentioned at the beginning, I'm sure I'll have more use cases next year, and I'll try and make them entirely non-intersecting with the ones this time. But those use cases are going to be driven by the guys from Brocade and the others who are writing the BGP code. So they're in the next session, but I think we have a break before that, if I remember right. I think it's like a 10-minute. Hang on, let's check. Here's the schedule. Is that today? Yes, that's me.
Yeah,
Yes, there you go. And I'm 5 minutes early, and then we have a break for 10 minutes, and then the other guys, and I think they're in the same room, but let's check that.
401, 402.
Great, excellent. Well, we've got 5 minutes left, so any questions, any comments? Interaction's always good rather than listening to me.
What we've supplied here basically is the ability to read right into the network itself, just like Dave Meyer was talking about in his.
Yes, yes.
What's missing, for better or for worse, is commercial offerings that do, like I was talking about, collect the streaming bandwidth and actually do the computations and inject it back in, or detect those sort of situations you just talked about on the disaggregation.
Yeah.
BGP. But my point is, there's a lot of opportunities for people to make money here by writing some code and selling it.
You're not like sort of, what's the word, inciting me to quit my job or something, are you? That would be really bad and quite inappropriate.
I would never do that.
You'd never do that. Good, good. And I think that's also it's a bit of one for debate, isn't it, as to whether we'd expect third-party companies to come out with these applications, or whether we would expect the big SPs to build their own applications. And I guess we'll probably see a bit of a mixture of that.
It's both. Yeah.
Yeah. I mean, the other use case, which I wasn't demoing here, but is one I've been playing with a bit. Is this one of, how do you enable the OTT CDNs to locate the nearest cache to a user? And if you look at Akamai, Google, Netflix, et cetera, they all have different standards really for how they want you to advertise routes. So I think Netflix uses meds, Google and Akamai I think both use communities. But for you as a carrier, you've got to figure out, well, how do I take my communities and how do I translate those into meds or the other guys' communities in order to advertise such that you can direct to the nearest cache. And I think it hasn't been such a huge issue up to now, because generally what you've seen is the OTT CDNs putting a small number of caches into the sort of core locations of the service providers. But of course, we're reaching a point now where I think it's, from everything I've heard in the US, I don't know if anyone here could confirm that, it's something like a third of all inbound internet traffic to the user is Netflix, a third is the other OTTs, and a third is everything else. That kind of number. And at that point, you've got to expect the likes of Netflix and Google and Akamai to want to push caches closer to the user. Now, if you're an SP and they're your caches, it's fairly easy to get it right. But if these are third-party ones, I think that's where we're going to need some machinery. And again, that's where I think BGP is probably a great way to do it, in that they all accept either communities or meds. And where, again, because some smarts are required, that's where you probably want a platform like OpenDaylight to do that. So we built a demo a while ago using BMP to learn stuff, and then BGP to push it into the CDNs. And so those sort of things are out there as apps. But as I say, I think it's really up for debate as to how much of that is driven by the SPs themselves and how much by commercial offerings. But it's certainly going to be an interesting time. I think there's, having opened up almost like this, BGP has always been a protocol that's given you enough rope to hang yourself with. What we're doing here is we're opening up another degree of flexibility, which I think is going to open up a whole bunch of new applications. Which
Make more rope.
yeah, we've just made some more rope. Yeah. So,
Different color and more of it.
yeah. So it's going to be interesting times. So yeah, thanks everyone for coming. And unless we've got any other comments, we'll call it a halt and have a break. And if you're anything like me, you're then going to go and watch the video of Brian Freeman that we missed. Slides on that, and some other approaches to DDoS mitigation. And then finally look at BGP and how you could look at overriding best path selection using BMP. There's a couple of options there, and we can go into that. And I can show you some of the infrastructure, and 100% get that one running. So the overview. So here's how it all fits together in terms of OpenDaylight. So the two southbound plugins, PCEP and BGP. BGP is used to learn routes from the network. Now the thing is that, as I say, we kind of started with this for BGP link state. What's happened over time is more and more address families have been added. So BGP itself started out as IPv4, of course. And then what happened was multi-protocol BGP was developed, where using the inherent extensibility of BGP in terms of TLVs, we could just add more and more address families. Be interesting to actually get a sense of the room. How many people here would say they were software developers? So perhaps a third. And how many would say they were network designers, architects, etc.? So perhaps slightly more on the network side. So I guess most of you guys are probably well aware of BGP already. And so over time, we've added these additional address families in ODL. So IPv4 and IPv6 unicast, labeled unicast, so that's RFC 3107, where you have a route that's advertised with an IPv4 prefix, but also with an MPLS label. Flow spec, initially I think that came in Lithium and was v4 flow spec only. I think over time that's something we'd like to make programmable. And I think the question then becomes, do we do that using sort of route policy language, a la what you might do in XR or Junos, et cetera? Or would it be better just to provide some way that people could plug in their own policies using, whether it's done with Yang models or whether it's done by putting in Java code? That's something I think we need to look at. From that, we build an effective ribbon. Now, the effective ribbon really is the routes that have passed policy. So typically, again, on router, this is where you'd say a route policy whatever in, and you'd filter out routes that you didn't like. The next part is the decision process. So I can see Bo sitting over there, and Bo, I'm sure, and in fact, Chris in front of him, I'm sure these are both men who once upon a time would have had printed out on their cubicle, or in Chris's case, if he was in the UK at that point, printed out on his desk, because we don't really do cubes, a thing saying this is the BGP decision process. And you could download this from the Cisco website, and it went from, was it 1 to 13 or something, the different steps in the decision process. And we all had that. I mean, I was a network operator back in the day. And you always had this thing written up there, and great. You knew the process by which you decided which routes made it into your lock rib, which is the output of that decision process, and which ones didn't. Now, again, this is where I can see the value in us becoming more flexible in OpenDaylight, because ultimately we're not a router. We don't have a fib. What we have is topologies, which we'll come on to next. So there might be value in being able to do different forms of best path selection to get into that lock rib. And we've got some ways we can override it, either by spinning up multiple ribs or doing some tricks I'll show later. As of Beryllium, it has v4 and v6. And then also IPVPN and EVPN, but those are new in Boron. And as I mentioned at the beginning, it'd be probably good if you want to know more about those to wait for the next session, which is going to be the guys from Brocade talking about some of the new things in ODL BGP. That's actually one point, I guess, to make now, is that initially, ODL BGP, we were very much driving it from Cisco. One of the great things as this community grows and builds is we've got more developers coming in and making changes to it and committing things. So we've got the team from Brocade. I was noticing actually a bug that I'd raised the other day relating to EVPN, and I was noticing that a patch had been provided for it, and that was actually done by somebody from AT&T. So we are seeing developers coming in from other organizations on this, so that's great. So this slide I'm bringing up really because it's better than the one I did last year, and this is the one the Brocade guys showed the other day, and I think it's actually really helpful in terms of understanding the pipeline of what happens with BGP routes, but also some of the things we might want to do in Carbon and beyond in terms of potentially changing how we do this. So for each BGP peer that you will have an adjacent ribbon. So this is absolutely standard BGP stuff that all routers do. The adjacent ribbon has every route you've learned from that peer. You apply an import policy. Now in OpenDaylight, the import policies aren't programmable. They're very basic in terms of, is the route basically legal? Does it have our own AS in, that sort of thing. Right. Unfortunately, I guess we got scheduled against Brian Freeman, so that's probably why there aren't so many of you here. I'd much rather be listening to Brian Freeman as well. So, yeah, real shame on that one. But yeah, what I wanted to do was just give you kind of an update on OpenDaylight BGP, but particularly with a focus on use cases. I don't know if anyone here was the tutorial we did on Monday. 1 or 2, yeah. So we did a tutorial on Monday afternoon. And I did that along with 3 of the guys from Brocade. They're coming in after this to do a talk more about sort of what's new in ODL Boron with respect to BGP. So what I wanted to do was focus on use cases that were already there as of Beryllium, rather than looking at some of the new stuff. So I was going to give a very brief overview of the BGP plugin and the PCEP plugin and how the project hangs together, and then look at these 3 use cases. I'm afraid I failed to stay up all last night hacking, so the use cases may or may not work, but I sacrificed to go to the demo gods, and there's some hope at least. So the 3 I wanted to look at, one was traffic optimization using BGP and PCEP, and this is really where ODL BGP came from, this concept that we can use BGP LS to learn stuff about the network, and then use PCEP to program LSPs into the network. For a bit of added fun today, I'm going to attempt to use segment routing. This is in some ways similar to the demo I did last year, but in that case it was using RvesvesD. Then go on to look at DDoS mitigation using FlowSpec, and I'll show you some slides. We can learn from BNP and push out with BGP, those sort of things. But ultimately, it might be good to have more flexibility as to what decision process we adopt. I mean, you could imagine, a Yang model that literally has the default is here are the 13 steps in order or whatever, and you can just play around with it and reorder them, those sort of things. So, as I mentioned, for each peer you spin up an adjacent ribbon. For each peer you spin up an effective ribbon, but you still only have the one lock rib, and that's because you're building one rib for the routes from all the peers. Sorry, I kind of change at will from English to American. I'm really sorry. Routes, you'll forgive me, I'm sure. Now, if you're acting, more or less as a router, what you then do is you apply an export policy, which again in OpenDaylight isn't programmable. You build an adjacent rib out, and again you build one of those for each of your peers. Now, the thing there is this is sort of the normal sort of route reflector kind of use case, I suppose. And that is one use case we could use OpenDaylight for. But I suppose what we probably see more than this is examples where either we're using BGP just to learn stuff, or where we're using it just to program stuff. And in the context of using it just to program stuff, this is where the application rib comes in. So if you think back to Yang models, and again, anyone here who's has more sort of OpenDaylight experience probably has the head a little bit around Yang models. So any data in a Yang model is marked as either config or it's not config. And what we do from that is we build the separate trees, the config tree and the operational tree. Now, the ribs are all operational data because this is all stuff, as you can see on